Good morning, good afternoon, wherever you are. It's Matt Coleman, your host from Magnify World. I'm speaking from our Los Angeles studio. And today we have another very special guest from San Francisco. Timoni West is the Director of Product of XR at Unity Technologies. And San Fran, how are you today?
I am great. I'm as good as I can be. Obviously, the fire is on everyone's mind today, but yes, otherwise doing quite well.
Yep, no, we wish you well. And it's passed here for a little bit, but we'll soon see what happens. It's going to get hot for another month.
Yeah.
So look, you've been at Unity for a number of years, nearly 6 years. And can you tell us a little bit about your role? But before we get into this, maybe just tell us a little bit how you got into the industry, because I noticed you had a design background. Can you tell us just a little bit more about that?
Yeah, absolutely. So I've always really been into computers ever since we got one at school back in the day. Was always really interested in, it's funny, even now that I think about it, I didn't know it was called that at the time, but I was doing a lot of ASCII art on old text-based processors. I would design my own custom icons before I even knew what that was called. So I was kind of really gravitated towards, not only using computers, but trying to make them better in my way. I got in when I was in high school and college in the 90s. Obviously, the internet was starting to become a thing. So I had my own little business making websites and really just kind of moved on to working in computers ever since and kind of moved up. Obviously, I had to move out to San Francisco at some point because that was really, obviously, for America, the tech capital. I worked at a variety of startups in a variety of capacities. And while I never sort of thought to myself as a being sort of always about what I would now call emerging tech, it was always about what was the most interesting cutting edge thing to do. But in the 90s, it was a web page. And in the 2000s, it was, I designed the first smartphone page or application for quite a few different startups. So it was always kind of like, what is the next interesting digital medium that we can really take and expand and kind of make better and better. And I worked a lot in consumer, C2C or B2C. And I decided at some point that I really wanted to dig in not only into helping consumer and share, but also help kind of at more what I thought of as the ground level with these tools that people depend on for their livelihood. These really hardcore professional grade tools, as I like to call it. And I had worked with the now VP of Labs, Silvio Duan, on and off for years at a couple of different companies, in between my own co-founding a few startups. And he decided to start the Labs team in 2014, and I called and asked if I was interested in joining on. Virtual reality headsets were just on the market. The Oculus had already been out, but it had just been acquired by Facebook. I have to admit, the first Oculus, I couldn't stay in for very long without the tracking. I definitely have a little bit too much of a weak stomach for the V1 headset.
Do you remember what that experience was, by the way? Because my first experience was a roller coaster, which wasn't good, I can tell you. And that's the worst thing you could give someone, actually, if they hadn't tried it.
That is absolutely the worst thing. Yeah, I did this really cool Paperboy experience at I/O where they had set up a bike and they had a fan blowing on you, and you put on the headset and then you would throw the papers, and at the end you went into a brick wall. Very funny. That was with the original DK1, but the DK2s were out by the time I joined Unity, and the Santa Cruzes and the tracked controllers were on the way, and we got a Vive probably within a week or two of my joining. So it was exactly the right time to start exploring what can we do with this new media, with this new hardware, to really push 3D creators, people who want to make interactive applications, to be able to make really cool stuff. Things that are, when you're dealing with working in 3D on a conventional computer, you're really kind of dealing, you're moving your mouse and you're moving a hotkey and you're switching how you move around in the space. And it's all really kind of like with a remote control. You're never actually interacting with the object. So we're really excited to see now that we have the headset and now you can be in the digital world actually creating, what does that look like, right? And how can we unlock this for a wide variety of creators? So that was a really exciting time to join on at Unity.
Look, tell us about XR tools. I mean, you're the director of product. Can you just describe what your version of XR is? I mean, love to hear that, and also spatial computing, and that's part of your role, of course. What are your focuses?
there's much debate in the community about what the words should be. I will say that Unity chose to embrace XR because saying augmented mixed and virtual reality every single time is really tedious. And it also kind of future-proofed us because X is just a variable. So then if another type of reality comes on board, we can just, it's still covered. I think most people are aware of Milgram spectrum. We have, virtual reality all the way up through real reality, if you will. What I would say combines all of the different realities that we're talking about here is that at some point there is a direct connection between the digital world and the real world, whatever that connection point may be. It might be very loose. In virtual reality, you really only need to know not even where a human is, but just where the headset is and where those controllers are. So in a sense, it's actually just a computer talking to another computer. Like the human kind of interact with the controllers, but it's not body tracking, for example. It's not face tracking. It's not expression tracking. It's really just tracking, other parts of the computer in space. So that's that one end, but there's still that world data there. Where are those controllers? Where is that headset in space? What's happening there? And all the way on the other hand, we have mixed reality where which is an incredibly ambitious attempt to be processing everything you can find out about the world in real time, translate it back on the device, and then render a frame that looks as if it's interacting with that real world data, right? So, you're wearing a headset, an AR headset, and not only is it have 16 cameras all pointing in different directions, trying to make sense of the world, and then loop that back in, but then within that fraction of a second, you need 60 frames a second in order to not get sick, be able to then render a frame that makes sense in that space where the ball will bounce off the table onto the ground with real world physics. So we're just at the point that computers are anywhere near being able to take in that level of information, process it, and then render back the frame in something approaching real time. And I think it's tremendously exciting. The fact that we can have untethered devices that can do that at all is kind of mind-blowing, right? So those are the two ends. But the thing that really combines them both, again, is that real world data. And Unity is kind of a uniquely amazing tool for making apps that run in the real world because every single game you can think of requires some level of interactivity. And what is that? Just a human doing something. So it's a human hitting a B button to push a sword. It's a human tapping on a solitaire game and dragging over a card to complete a deck, right? Every game intrinsically assumes that there is some amount of real world data. Most of the time, just a person playing a video game, strafing around, moving the camera, but it could really be anything. And that's why we can do things like have wake words or gesture recognition or any other type of world data so elegantly go into Unity to run these real world applications. And so that's why we tend to think of it not just as XR, that's just a convenient shorthand, but spatial computing as a whole really is about not just wearing, an AR headset and having digital objects in space, but then where does your phone fit in? So, your phone is no longer the display because your glasses are the display. So what does that make your phone? Maybe it's the controller. Maybe it's just, the tracker tracking you around. Maybe it's the gyroscope. Maybe it's your microphone. By thinking about these devices so holistically and working together in space, in context, it allows you to really kind of take each device for what it's best at, right? Glasses are best at displaying information in context better than a phone because a phone is always, again, a static kind of window. But a phone is a lot better if you just want to pick up and move something around in your wrist. So what are the tools and what are the applications that are best for each of these devices?
You just mentioned before, I think 16 frames per second. Tell us about how was that important and where does that come from the early days of 5 years ago? When I say early days, I'm talking about my roller coaster experience.
So these are just
tell us more about that.
Yeah, movie, TV show, anything you see that moves, games included, you have to render a frame. And if it's a very high definition movie, like a Pixar movie, it can take used to take days, now it takes hours to render a single frame for a variety of reasons because the scenes are very complicated, it looks very realistic, etc. This is why, movies always look better than video games because video games don't have the luxury of taking hours or days to render a frame. They have to do it really, really quickly. And the reason is that if we have too much of a gap between frame to frame rendering, humans start to feel queasy. Now, in video games, traditional 2D video games, the golden standard was at least 30 FPS, 30 frames a second. So that's if I'm looking at a TV and I'm playing a video game, that's kind of the minimum you want for smooth. Higher is better, but that's the minimum. So if you're playing an FPS, there's two reasons too. Not only does it make you sick, but if you lose a frame or if there drops as you're like turning around and you're playing a really high velocity game, you might have gotten shot and you wouldn't have even noticed, right? Because the frames were dropped in the meantime. So that's your standard there. The minimum for mobile VR and AR is 60 frames a second. 60 can still make you pretty sick, especially in VR. AR is a little bit more forgiving because you have both the digital object and then also kind of the world around it. So it's not like the whole world feels like it's juddering. But for virtual reality, high-end virtual reality, the minimum is 90 frames a second. Anything less than that, and humans can start to tell that something's a little weird, moving side to side or moving up and down, and then your body instantly goes into, okay, something's wrong. I'm sick. I'm poisoned. I'm drunk. Time to throw up. The body's classic response to everything. And actually, there's some really interesting technical problems with this. For example, like they had to change the types of lights that were used in HMDs just to get very geeky for a second. The conventional LEDs burn a little bit bright and then they ghost out. So you have to you want to make sure that you don't have a ghost imprint. But also OLEDs kind of burn out from, I want to say it's like left to right or right to left, whichever it is. So if you move your head up and down, it's actually okay. But if you move your head left to right, you start to notice that strafing effect a little bit more. So frames per second was kind of made as a gold standard to kind of avoid those limitations of the technology itself.
That's great. I'm glad you're explaining this because a lot of people don't go into this detail, but it's really important for the developers.
Yeah, absolutely. Yeah.
Excellent. So look, let's talk about Mars. Tell us what Mars is. Obviously, I know it's an authoring solution that you offer the development community, but, go into some more detail around that because it's only come out this year. Tell us more about what was the drive to get this out to market because it's quite an exclusive development tool and environment, right?
Yeah, it's been a labor of love for the past 2.5 years, and it was really driven by the desire to allow our developers to make the tools that they want, or to make the experiences that they dreamed of making. So we talked to now over 100 companies and developers who have been making augmented reality, and what we heard again and again was they had this vision of what they wanted to achieve, and the reality never came close because of unknown or unexpected and unanticipated problems. So what we hope Mars does is solve those problems. An example problem could be that build time, iteration time is extremely long. You have to make a build of your experience, put it on the headset. You might not even be in the right space where you're actually going to run the app, but let's say it could run anywhere. Then you have to go, walk around. Well, it didn't work. Go back, sit down. Maybe it's designed to run on a big table, but you're at the office. You don't have a big table. What you going to do then? How are you going to test it, right? So to sort of answer those questions, you might not be in the space. Even if you're in the right space, you might not have access to where you need it, or it might need to run in any space gracefully. We created something called the simulation view, and the simulation view pretends to be the real world, pretends to be your app running in real time. And you can even walk around as if you're wearing a headset or holding a phone, scan up this simulated space, detect information about it, and then you're on your app in the editor. So you can just quickly iterate. And, of course, it'll never be completely the same as when you run it in the real world, but we can get you to good very quickly and just to test out the basics. So that's one thing. Another thing is that in movies, we often have holograms instead of people wearing glasses. And holograms kind of are just standing there in space, Princess Leia, when she says, "Help me, Obi-Wan Kenobi," is like coming out of R2-D2 and kind of facing Luke Skywalker and Obi-Wan, right? Obviously it's a movie, they set it up like that, but so then the question is not a hologram, right? It's got to be glasses or it's got to be phone. And I'm walking around space and I want to have this hologram appear. How can I make sure it's always facing me? Or how can I make sure it's always on the ground? How can I make sure that if there's another person in the room, it's kind of facing both of us as best it can? Where should this be placed? And that led to a whole bunch of logic we created to help you place objects in the most sensible location. Find the floor. If you can't find the floor, find the nearest flat surface. If it has to be on a table, look for a plane that's elevation of this far away. If there are multiple HMDs, take, the difference between the two angles and then place it in the middle there. If you need something to be seen by the user, don't even render it in the frame. Don't even start the animation until they turn their head and it can start to be rendered, and that's inside that field of view, things like that. So we call that the proxies or the condition system. So under what conditions does my app need to run? And then within that, even if you're, putting just, let's say, a little game on a table, you might want to have certain rules around how it's laid out depending on the size of the table. So I'm making Zelda. I always want the castle to go in the middle of the table, right? But maybe I want the bridges to be on the side. Like all of this internal logic around best, not like level of logic, but just if I'm in a real space, what do I need to see? So we have something called forces that allows objects to kind of gracefully realign with each other, and then landmarks to help lay out as well. So a whole bunch of systems just around how do you actually get something to be where you want it to be in space when you don't know what that space looks like? And then we also have the companion apps, which run on mobile phones and HMDs and allow you to sync your project assets and then just lay out things in space. Kind of the dream, really, of just being able to be like, why can't I just use my phone to do this? You can be anyone. You don't even have to be, a Unity developer, but someone, can hand you a phone with the project assets. You're, in your museum, making image markers for every painting, putting a little label next to them, typing in the text, and then you sync it back up to the cloud. It goes back down to the Unity editor, and then the studio you're working with can finish up making the app.
So I know we were talking before about some other examples in architecture and the automotive industry. Tell us a little bit about where that is and what the potential is of that.
Absolutely. Yeah. So I would say for both industries, there are multiple places where contextual information is really useful. So starting off with architecture, we not only have our own tool, Reflect, which allows you to render very high definition, very, very information rich, and then also externally on a site. And we also have a great partner, Shop Architects in New York, which have done something similar, where they have an actual iPad viewer that allows people to go on site, and actually view a very high definition, beautiful rendering of what the building will look like in situ. So really, really kind of making good on that promise of bringing contextual information to life, right? Like what if, I don't want to just imagine a building being there. I don't want to just see the building and have someone point and be like, it's going to be right there. I want to be able to actually, use Unity and use the power of the device to be able to actually see the information in context. So that's all extremely exciting. But in architecture, and that's kind of two parts of it, right? That's both the BIM information and then also the rendering, which are two parts of the process. But even, during the construction phase, checking against blueprints, during the final phase, being able to see real-time information about the infrastructure of the project, all of these things are things that where contextual information and therefore Unity can be a useful part of the process and part of these applications. For automotive, again, the same thing. There's a lot of different points. So, we've had major automotive companies have used now virtual reality for years and Unity for years to do visualizations of what would normally be sort of during the clay car component or part of the process where you're kind of validate you've got the look and you're trying to just see whether or not this passes on to go on the next phase of pre-production. So there's that aspect. And also the initial brainstorming phase, you can use, I believe Gravity Sketch is made with Unity. You can use it to actually sketch out very technically accurate automobiles. So yeah, pre-production, previs phase, and then going all the way or even post-production, working on things like self-driving cars. Well, actually, let me back up. Not even that, but heads-up displays, for example, being able to ingest real-world information as you're driving and then have a heads-up display that, tells you which direction to go or road blockers that are coming up ahead or other information that is more useful to have, sort of in context and in front of you as opposed to kind of down below and have to move your head back and forth, right? So it's just a safer way to drive. And all of that doesn't feel like interactive, maybe. It doesn't necessarily feel like a game because you're not interacting with it necessarily. But the fact is, Unity is useful here because Unity is interacting with the data, right? It's continually feeding in the data, figuring out what needs to be displayed to you next, and then turning it back out on the display. That real-time 3D. Finally, with things like self-driving cars, looking towards the future, you're taking information from the real world and then using it to actually to control what the car does next, to see a stop sign, slow down. How far away is the stop sign? Okay, slow down more quickly, slow down less quickly. unidentified object in front of the car, brake immediately, all the different things. And it's kind of like robotics. I mean, it is robotics really, but it's also kind of like a game controller, right? Where instead of, again, there being kind of a human controlling what's happening, the real world environment itself is actually controlling the car. So yeah, so from beginning to end, Unity, having that real-time interactivity can be, well, not just that, the interactivity, but then also the real-time visualizations can be useful at any part during the process.
Just going back to architecture for a moment, what about smart cities and the future of the infrastructure around the architecture of the existing city planning? Have you seen a lot of use in that area?
This is something that I think everyone thinks about quite a bit, and it's certainly under discussion. And I have friends who are working to kind of open source, for example, different systems that different cities have come up with, and make them more widely available to other cities. There's a whole consortium in Europe that's working on this now, and I think it's really cool. But I think we're still in the beginning phases. But that being said, I think it's not a big step to imagine that the way Unity is made to make these extremely large-scale worlds with enormous amounts of inventory, enormous amounts of players, enormous amounts of mini games or different types of game systems. Like at some point, it just is kind of a city, right? Like you're just taking in the real-world information and adjusting as needed. So, I think this is a shared vision that is known by many and even mentioned, in movies and so on. But I think we can really easily start to see a path where, as we kind of come together as different cities around the world and start to codify what that looks like what does a traffic system look like, or a traffic light system look like, or, even things like garbage collection, then how can we use that both for visualization, but perhaps even for interactivity? Like, how do we adjust things based on real-time information?
And obviously entertainment and education are, a big part of what Unity's been able to offer the communities. What are a couple of the highlights? Education's gone through, completely upended every part of the market here, obviously. I mean, what sort of effects have you've seen with COVID, coming in a number of months ago? I mean, a lot of the clients that I'm talking to are clamoring to know more about, development tools and augmented reality and XR products, particularly for training as well, actually. It's something that obviously collaboration as well. What are your thoughts on all that?
Yeah, actually, it's funny you mentioned we actually shipped with a training tutorial specifically because we've had that requested so much. So it's actually available with Mars today. You can just download it, and we have a factory interface that we use as an example, but can be used for any kind of training whatsoever. So it could be educational as well. One of the big challenges that we have right now is that we have a really high demand for hardware at a time when the hardware supply chains have been a bit limited. So it's a little bit chicken and egg. I was really proud to see and enthused to see how the Quests have been selling out basically every time on the market. Now the new one is even better. It was just announced a few weeks ago.
Yeah.
So I think as that low cost, untethered, doesn't require a PC, and relatively easy to use, easy to get to good hardware is available on the market, we will start to see that really take off in education more. I know people are interested in it. I know that the teachers are dying to kind of give kids the ability to learn that information in context. And in the trial runs we've seen, when schools are funded enough or have brokered deals to be able to get access to the hardware, kids' retention is higher. Other ability to grok what the actual information is higher. There's something to being able just to see something. You can see a picture and you might forget that picture, but if you're actually seeing Mars in front of you, the planet Mars in front of you in virtual reality, it's quite a different experience, right? I think we all get the value there. So really, I think at this point, it's just a matter of getting the headsets into people's hands. And on the flip side, on our end, we've realized that there's a need to come up with better solutions around things like networking so the kids can be in the class together, right? It's been a little bit of a challenge historically. It's no one's fault. It's just if things are networked, they are less performant. They require more processing power because then you have to make sure not only that that the same object is rendered on every headset the same way, but you have to update its position relative to everyone else. If people can move around objects, that means you have to move, that one copy of a planet, on 50 different headsets within a limited time span. And the games, the massive multiplayer online games have really pushed this tech significantly over the last 10 years. So it's not like it is a solved problem. It's just a matter of applying that technology that has been done often in-house or on a project-by-project basis, and making it available to places like education. But in the meantime, I think kids are really increasingly getting used to the idea of learning in a game and being able to edit that game world and being at that kind of be in the process of playing a game. And I'm really excited for that, because just playing a game is great. I love games. I play games all the time, my video games. But I always, like back in the day when I played The Sims, I would definitely use that cheat code to give myself like $1 bazillion so I could just decorate the house, or play like SimCity 2000. And instead of really playing the game, I would just like raise the whole thing and then just build the city of my dreams, And I think that there's the mod tools, the modding community, the open source community, and even games that are just kind of fun games that are just more creation tools, really speak to kind of that need and desire and ability to create. So I think we'll see even maybe a little bit convergence in that, and in education as well. You're not just learning in a world, but you can actually, shape that world or do cool creative things with that world.
Fantastic. And look, just a couple of last comments. I know smart glasses are out, but they are getting smaller. Obviously, Facebook Connect, that conference that was about a week ago, they were talking a lot about the technology and the haptics and the hand movements and eye tracking and even a Ray-Ban look, right? And you've got Apple, talking about their new smart glasses. So it's quite an exciting time, really, in the next few years, I think, for developers. What are you guys looking forward to? You must work hand in hand with a lot of the manufacturers.
Mm-hmm.
But did you think smart glasses is a game changer like it should be? I'm really, there's obvious uses for navigation and shopping, travel, etc. Yeah, what are your thoughts on that? Just to finish up here.
So I really want to be smartful, really too many. I really want to be thoughtful about smart glasses. I think that it's obvious to come up with some use cases that are really compelling that you probably will use every day. But there is a true danger of information overload, fatigue, applications that you don't want, that feel invasive, that might lead to the whole thing not working, right? If we don't do this correctly, if we aren't really thoughtful about what we show and why. My friend Silke Miesnix, who's the director of emerging tech over at Adobe, put this really, really well. She said, what do glasses do? They help you see better. And I think that is a key value prop we need to think about as we design these glasses over the next few years, or start to bring them out to the masses. I don't think the phone always got it right. I think sometimes, even now, I get notifications that I don't care about at all, and then I have to swipe them away, or I have to remind myself to go, notifications, turn off notifications. What I really want to see, I actually gave a talk on this a few years ago, was subtle information and context based on my daily habits that the computer can learn, that give me what I need to know when. What I don't want to see a calendar day to day that just shows me everything that's happening in my calendar my day. When I wake up, what I want to see is, how long do I have till my next meeting? Maybe who is that with? Just that one thing, right? Just at that moment. The rest I can check later. If I look down at my coffee machine, I don't need to see where the beans are from. I don't need to see what the water temperature is. I don't care. What I need to see is how many minutes until the pot is ready. 2 minutes, that's all I need to see. That is the true information and context that we need. And I think in order to really nail it, we'll have to be really humble about differentiating what seems like an obvious win versus what is the real win here. What do people actually want to know? So I'm tremendously excited for AR glasses. I think they are essential. I think they're the thing that people always wanted out of computers. The same way we want to talk to our computers, the same way, like we want holograms. Like I think they are inevitable, but I think, we've learned a lot over the last few generations. And I think we have enough information now to start making ones that will really actually enhance people's lives.
Fantastic comments, Timoni, and I really appreciate your time today.
Sure.
and a glimpse into the future. And it sounds like you're onto your next research project, which we'll hear about in the coming months, I assume, or years, as you're the head of research, of course. Or director of product, I should say.
Director of
so that was your last role, wasn't it?
Yeah. Yes, research before, now we moved in product. Exactly.
Hey, so thanks very much for catching up today. I know San Francisco is a bit hot and the fire's there, so have a pleasant evening, and we shall catch up with you soon. Thanks for your time.